In this video, we will cover how to use open source Llama 3 model with LlamaIndex. We are going to use Ollama to procure Llama 3 model. First of all, you can navigate to this website, ollama.com, and then you can click on this GitHub link. It will route you to the GitHub repo for Ollama, and then you can scroll a bit down, and here you can see the download link based on your operating system. First of all, we have to run Llama on our system, and if you want to run Llama on your system, then there are several options. You can also run it via Docker, or if you want to go ahead with any of the operating system specific installer, then you can also download it from here. So I'm using Windows. I can click on the download button, and it's going to give me an installer which I can install it just like any software. Once this gets installed, you can just search Ollama from your Windows, and as soon as you click on this one, you can see an icon over here. It means now the Ollama is running on your local. Now to check like what kind of models we can utilize under Ollama, so there are specific model libraries. So you can see it supports all these kind of models. If you want to run Llama 3, then we do have two models over here, which is 8 billion parameters model, and then there is a 7B. To run this model on our local, then we need to have this, we need to make sure to have this kind of storage before actually we run this model. In our case, 8 billion parameter is a bit smaller and it's easier to run on our local. So in our demo, we are going to utilize this 4.7 GB model. So now as Ollama is installed, let's go ahead and see like how we can run this particular model. Let me go to my Visual Studio, and then let me go to my terminal. And once you go to your terminal, you can just run Ollama run and then Llama 3. Now you can see all these commands are coming from here. So if you want to download Llama 3 8B parameter model, then you can run this command. If you want to run 7B parameter Llama 3 model, then you can run this command. But in this case, you need to have this kind of storage on your local machine. So let me just try to run this command now. If you're trying to run this first time, it's probably going to take some time, because it has to download that 4.7 GB model on your local machine. So I have already done that step earlier. So you can see like it just initiated very quickly. But yeah, if you're trying to run it first time, it may take a while. So now the next thing what we need to do, like we are going to write a very simple code over here using Ollama, and we will call this Llama 3 model. And then we are going to utilize this complete endpoint just to see we are able to get response using this Llama 3 model before we can go ahead and create a full-fledged application on our local machine. So let me just try to run this now. And you can see over here, we were able to get the output. It means all of the setup is correct. We are able to get a response also. Now we'll try to write an application using Llama 3 model. So let's start with our input data. In this data folder, 2 text file and 2 PDF file. And we can go to this PDF file. I have created this PDF where like one PDF is related to how OpenAI trained ChatGPT. And there are like some description under this one in the formatted way. And then there is another PDF where we have a detailed of how Shopify scaled their databases. Let me just try to close this. Other than PDF, we do have 2 text sample files also. Now the first thing what we are trying to do, we do have in this data folder multiple files, but we just want to utilize the PDF one. So the first step would be to load this data, and to load this data, we are going to utilize this simple directory reader. The simple directory reader comes from LlamaIndex.core, and we just have to pass our folder name over here. So you can see we are not passing any file name. We just have to pass a folder name. As soon as you pass a folder name, it will take all the files which are available over here, and it will try to ingest it. Other parameter what we are using over here, you can see like there are a lot of parameter in this one, but one more parameter what we are using over here is required extensions. Using this particular parameter, I am controlling what kind of file I need to load it from this data folder. So here I've just passed the PDF. So it will skip this text file and it will only take this PDF file for the processing. So once I have this loader created, I am just calling load data method, and this load data method will help me to create a document object out of all this data. So this document object is a base for LlamaIndex. So if you want to pass any kind of text data, first of all, we have to convert it into document object. So in this case, it will be converted using this simple directory reader. Now, because we are trying to use open source model, so the next thing would be to convert these documents into embeddings. And to convert it into embeddings, we are going to utilize one more open source model. This is from Hugging Face. And to call this model, we are going to use this particular method, resolve embed model. This also comes from LlamaIndex.core.embeddings. If you want to utilize any other open source embedding model, you can go to this particular Hugging Face embedding leaderboard, and from here you can select what kind of embedding model you want to utilize for your use case. So here it will give you the size, it will give you the parameters on which it has been trained on. Just take this particular model and just try to search it over it. It will give me the ranking of this model which I'm trying to utilize in this case. And you can see the model which I'm using over here, it has 38th rank and it is having 33 model size million parameters. You can also try different models. The pattern is going to be same. Once you call this embedding model, you can just store it into any kind of variable. Here I am using embed model, and after that I am just passing a prompt. This prompt would help me to pass my custom instruction for this model. You can use it or you can just remove it. It's very much optional in this particular use case. So this particular template we have to define, and then this particular template we have to pass it using this prompt template. And this prompt template is also going to come from this LlamaIndex.core. Now once you have this prompt template defined, you can store it in a prompt, and this prompt we can update it in our query engine. So query engine is going to have its own prompt. What I want, okay, instead of using its default prompt, use this particular prompt. So I'm just updating a prompt over here. If you don't want to use your custom instruction, then you can totally remove it, and this update is also won't be required. So we have defined our embedding model, we have defined our template. Now the next step is we have to call our LLM. As we have seen in our demo, to call this Llama 3 model, we are going to utilize this Ollama. Ollama is going to come from LlamaIndex.llms.ollama, and once you have this Ollama instance, then actually you can call your model. And the other parameter that you have to pass is request timeout. What I have seen in the documentation, the request timeout is very less over there, 30 seconds or something, but I have tested it with the 30 seconds. I have tested with 300 seconds also, but in this case, at least on my machine, I was getting timeout error. So I have just increased this time to 3000 seconds and I was able to get a response. It may take a while to get a response using all this open source model because you are running on your locals. It also depends your computing capacity. I am having 16 GB of RAM. Now we have to set it up so that like it doesn't go for OpenAI and it just refers the LLM model and the embedding model which we are referring to. So I'm using this settings over here. This settings is also coming from LlamaIndex.core. This settings should help you to define a parameter on a global level. So here I'm just calling settings.llm and defining the LLM which I have defined over here. Then I'm also setting the number of outputs. So if you want a descriptive output, then you can just tune this parameter based on your need. This is num_output. And then we do have the embedding model also, which I'm passing over here. Now these parameters have been defined. Now we are using the open source model and open source embedding. The rest of the steps are going to be same. So we have to create a vector store index on the document which we are passing. Then we have to call our query engine. We are updating our prompt as I have covered earlier because we would like to pass our custom prompt. And then I'm just asking a query. So let me just try to call this particular method which we have defined and just try to run it. As I have stated earlier, it may take a while to give a response on your local machine. So we have finally got a response from our open source model. So I did ask like how does Shopify scale their database processing, and it has given me this particular response from this particular PDF. So this took a while to generate a response, but we were able to run this Llama 3 smaller model on our local, and we were also able to pass our document and get a response out of it using all open source model. So is there any available option to reduce the latency of the response what we are getting from our open source model? So one option is Groq. If you want to test out Groq, you can come on this particular website, groq.com, and here you can just type some message and you can just see the response what you are getting in how much time. So it's very fast. If you want to know more about Groq, you can go over the documentation. One interesting thing which you have to be aware of, this Groq is based on LPU, so it's a language processing unit and not on GPU. You can also go into the FAQ, and here they have just mentioned like why it is so much faster than the GPU for LLM and GenAI. This LPU, they have specifically built it for GenAI applications. So that's why the response which you are going to get from Groq will come with a very low latency. How we can get started on this one? So you need to click on this GroqCloud because I have already logged in. You can see this particular playground and the documentation in the API key. But if you are going to get started with this, then first of all, you have to register yourself. You can register with your existing accounts. And once you get access to this particular playground, you have to go to API key and you have to click on this create API key. You can see my API key has been created. I have to utilize this particular API key if I want to utilize the Groq capability. You can click on the documentation. and then you can go on the quick start, and here they have mentioned the steps, how you can get started and how you can integrate it with the code, so you can utilize this. Other interesting thing which I wanted to highlight is the models. So here you can see the supported models in GroqCloud. We do have an option of Llama 3 8B. We do have an option of Llama 3 70B also. In this case, because all these models are deployed over here, so we can just utilize Groq and then you can pass all this model. So let's see like how we can do it in the code. First of all, you need to install this particular package, pip install LlamaIndex LLM Groq. So if you do have it, then that's fine. If you don't have it, then you can install this particular package on your local. As soon as this is completed, it will give you access of Groq. So then you can import it Groq from here. Rest of the things are going to be same, and because we have to pass our API key over here, so you can just save it in the environment file. In this case, I have kept Groq API key and then just pass my key in single quote. And to get this particular API key from the environment file, we are going to utilize .env. And if you don't have it installed, then you can install it by running this particular command. It will give you access to load.env. So what exactly you need to do? You need to first run this. Now it will load the environment file, and after that you can retrieve the keys from here. Now the same thing what we did when we were calling Llama 3 using Ollama, the differentiator in this code is going to how we are initiating our LLM model. So in this case, you can see I am just initiating Groq instead of Ollama. Then I'm passing the model, and this model name I have got it from the documentation which I have shown you. So here you can see the model ID. I can also call Llama 3 70B. So let me just call Llama 3 70B over here, because in this case, this model is not going to be installed on my local machine, so I can go for the higher end models. And then I have to pass my API key over here, which we have defined over here. Now once we have our API key is also defined, it means like our LLM has been initiated. We have to set our LLM over here. So we are using the settings variable, number of output, and the embedding model which we have done earlier. Let's try to run this and see what are we getting out of it. Now you can see like in this case also it is spent some time to generate a response, but it was much quicker than what we have got earlier. You can compare the responses which we have got from the first one, and in both cases actually we are using Llama 3. So let's compare like how much time is spent to generate the response from these two models. For this actually I have written this Python code where we are going to have a start time before we run the first model and the end time when the model ends, and then we are going to calculate the execution time by subtracting the start time from the end time. And similarly we are going to call the Groq Llama 3 model also, and we'll see like how much time it has spent to generate a response. Let me just try to run this. So now you can see like we have got a response, and you can see the function Llama 3 took 72 seconds to execute. Ollama on our local, this took 72 seconds to execute, and the functions which we were calling using Groq, it took 37 seconds to execute. So it's approximately half of what this particular application took to execute. Yeah, this is all for this video. Thank you for watching.